All right, so hi everybody, this is Marie from the Innovation Group, and welcome to another Emerging Leaders of Gaming webinar brought to you by the Innovation Group. I just wanted to give you a brief overview on the functionality of GoToWebinar before we get started. So you should be able to see the file that I'm sharing with you, and this slide shows where your various windows are, including panelist cameras, this PowerPoint presentation, which is available in the handouts window, and the control panel. You can choose to follow along with us to view the presentation or download it directly and go through it at your own speed. The next slide shows how to expand any of these separate windows to go to full screen. Just click on the double arrows on the bottom right corner of your selected window, or to escape full screen, click those arrows again or hit the escape button. You can also minimize and maximize your control panel by clicking the orange arrow at the top. You'll notice that you're automatically muted throughout the webinar, but to ask questions, expand your control panel and look toward the bottom right in the questions section. Just type your question and hit send, and we'll reserve 10 minutes at the end to cover as many questions as possible. If you're on a mobile phone, your functionality will be slightly more limited, but you'll see your menu items at the bottom. To toggle back and forth between panelist cameras in the presentation, swipe from left to right, and to advance through the presentation on your own, since you won't be able to see ours live, swipe down for each new slide. The menu also shows where you can access the presentation, also called handouts, or ask a question. As for frequently asked questions, if you run into any technical issues during this webinar, call the GoToWebinar customer service team at the number that I've been displaying at the tops of all these slides. And we'll post a recording of this webinar on our Emerging Leaders page within a few days, so stay tuned for that. And now I give you to our Senior Vice President of Operations and Data Analytics, Brian Wyman, to kick things off. Brian?
Well, good morning, and thanks, Marie, for the introduction to the webinar. It's good to be here, and thanks everybody for jumping on the call this morning. Definitely, this is a topic that I'm pretty passionate about, and we'll talk about machine learning and its applications in gaming. To help me do that, I've brought an old friend of mine from graduate school days back in Michigan, Luis Serrano. Luis is the head of content for artificial intelligence and data science at Udacity. And so who better to bring on to share kind of an introduction to what machine learning is and how we use it than someone who builds content for a learning site around machine learning. So I'll let Luis give you a little bit about his background and then let him kick it off.
Thank you, Brian and Marie, for the introduction. Yes, so yeah, Brian says it's a pleasure to be here with him. So we did our PhD together back in the day. So we had wonderful math conversations, and now we get to have machine learning conversations. So it's great. And let me tell a bit about myself. Yeah, this is what I do for a living. I teach machine learning online courses, and I handle the artificial intelligence and data here at Udacity. We're an online education company. And before this, I used to be at Google for some time, working in a machine learning team. It was the YouTube recommendations team. So when you get videos recommended to you as you log into YouTube, then that was what we were doing. So we use a lot of machine learning for that. And so yeah, today I'll give you a sort of brief overview of some techniques in artificial intelligence and in machine learning. And this is going to be sort of a conversation with Brian, where he will elaborate on things and applications to gaming. I really want to encourage you to ask questions. You have the little box here on the side where you can ask questions, and I get to see them on real time. And I do like the interaction. Sometimes I will ask you questions, and I would love it if people can reply on the little window. Yeah, so let's kick in. So first things first, let me ask you a question. What is machine learning? So why don't you think about it for yourself, or post something in the window. Everybody has a different definition of machine learning. In particular, I have my own, and they're all valid. So I actually love hearing people's definitions. So any ideas on what's machine learning? While you think about it, I'll just ask Brian. Brian, what is machine learning to you?
Well, I have the benefit of knowing that this question was coming, and so I'm a little quicker to answer it than some of the folks who would have to type in the chat. But this is something that I had to think a lot about. I wrote an article recently on machine learning, and so I had to kind of formulate that for myself for an audience. And for me, machine learning is the use of a computer to do three things. One, process data, typically a larger amount of data. Two, to learn or make inferences from the data. And then three, to make predictions about something in the world. So for me, machine learning is processing data, learning from the data, and using that to make predictions about something in the world by a computer, not by a human.
Absolutely. Thanks for that definition, Brian. That's exactly what it is. And I see some interaction. I see Robin said is generalizing a prediction based on previous seen data. Absolutely, that's it. And Satyartha, sorry, I hope I pronounced it well, says the ability to make machines learn things through programming. So yeah, absolutely. It's basically the ability to make machines learn from previous data. So the way I call it, I have a simple definition. I call it common sense, but for a computer. So it's kind of like how humans think, trying to give that to the computer. So how do humans think, right? Like, let's think of common sense. How do we make a big majority of our decisions? Most of it through experience, right? Like we think, okay, I did this in a certain way several times, so probably if I do the same thing, I get the same results. Or if I made a mistake, if I try to do it in a slightly different way, I may get a slightly different result in this direction. So it's basically we model we make rules for our life based on our experience. And for computers, experience has a name. It's called data. So for computers, experience is data. So in the same way that we make decisions based on our experience, computers make decisions and models based on data. And I'm going to read a couple more answers. This Nicholas says, is the science of getting computers to act without being explicitly programmed? Absolutely. So basically getting computers to act based on data and not on a program. And Aaron says it's algorithms. Yes, it is algorithms. And today we'll learn a few of these algorithms. So I'm going to overview some of the three of the main sort of techniques that we have in machine learning. The first one is classification. The second one is regression. And the third one is clustering. So let's get started with classification. So what is classification? It's really just, as the word says, classifying things into different classes. So let's look at an example. My favorite example for this is an email spam classifier. So let's say we have our emails and we want to, we're sick of getting spam. So we want to write maybe a little line of code, or maybe make a little script on our computer to try to get rid of as much spam as possible, and also to keep the messages coming, right? So let me color the emails, the spam with a red envelope, and non-spam, which actually I found out recently is called ham, because it's like the real version of spam anyway. So we're gonna call them spam and ham. And an example of ham is just, let's say this lovely email from our grandma says, hello grandson, I made cookies, love grandma. And here's an example of a spam email that buy lots of money, cheap, buy free, etc. And so this is our example. So what do we see? Do you see any? What would you do if all you had is this information? How would you sort of any rules? If anybody wants to suggest any rules you would make for a very, very simple spam classifier? Anything you see, for example, that you see a lot in spam messages and that you don't see in non-spam messages? So I'm going to start throwing some ideas, and by all means, give me any idea that you'd like in the chat window. So here's one. It seems like maybe the word "buy" appears a lot in spam emails. Maybe there are more spelling mistakes in spam emails. So let's see if we can make rules based on those two. And obviously, they're not going to be perfect, because maybe maybe somebody sends us an email saying, please buy this, or makes a mistake. This is not 100%, but things that tend to happen. So let's actually look at the word buy, and let's actually sort all our emails and count how many times the word buy appears in each one of them. and just see which ones happen to be spam and which ones happen to not be spam. So we have for 0 word buy a lot of non-spam. And then let's say, this is purely hypothetical. I made up this data set, of course. But the appearances of word buy, the more times the word buy appears, the more likely the message seems to be spam. So we could make a rule here, right? Like, what do you think would be the best rule to make here? I want you to think yourself of what could be a good rule of thumb for sending things to the spam folder or not. Any ideas? Try to get this chat window. Oh, thank you. I'm just going to read some answers. Ben Wise. Hey, Ben. He's another friend from our PhD days. Non-letters surrounded by a word of letters. That's a good idea. When you have none, when you don't have letters and symbols and stuff, you may have things like capitals, money signs. Thank you, Satyartha, and those are good rules for spam. And Aaron says if you have bigger than 2 times the word buy, if you have more than 2 times the word buy, it seems to be spam. So that seems to be the rule right now, right? The rule says you're more likely to have a spam message if the word buy appears twice. So let's say that if it appears twice, it's spam. And if not, it's not spam. As you can see, it's not a clear-cut rule, but we're going to use it. So that's our rule. Rule number 1, if number of appearances of the word buy is bigger than 2, then we say spam. Otherwise, we say ham. So that's a rule. What about spelling mistakes? Let's say we count the number of spelling mistakes in our email, and we see that, again, the ones with few spelling mistakes are not spam, and the ones with lots of spelling mistakes are spam. So any ideas for what would be a good rule to do here for with spelling mistakes? Let's see if some answers come by. I'm going to throw my own. I think if you have 3 or more, if you have more than 3 spelling mistakes, then you're spam. It could be 2, it could be 3, right? The rule depends on us. But let's say that rule 2 says if number of spelling mistakes bigger than 3, then it's spam. And if not, then it's ham. So we have 2 rules, these 2 rules. Can anybody come up with other rules? Maybe regarding also the number of, if we only have the number of appearances of word buy and the number of mistakes, can you think of other rules? Maybe like using 2 of these together, combining them in certain ways. How would we combine these 2 rules? So I have a couple of ideas. Maybe we can just do the simplest thing and say, hey, what about the rule of the form? If you have more mistakes than these many, and number of times of the word buy appears is bigger than something, then it's spam. Otherwise, it's not. Like combining them using and operators, using or operators, using just logical operators. That's completely doable. Another one would be to just actually add them, right? Like add the number of times the word buy appears and the number of times a spelling mistake appear, and that could do it, right? So these are all valid rules, and we can actually come up with as many rules as we want. We can say let's say if 3 times the number of mistakes plus 5 times the number of the word buy plus 8 times something else is bigger than 14, then it's spam. And there's a plethora of rules, right, we can use. And all these are different machine learning algorithms. So let me give you some idea. The first 2 are actually an example of a decision tree. The 4th one is, as an example, something called logistic regression or the perceptron algorithm, if you've heard of it. And if you've heard this magic word, neural networks, that appear everywhere and are super popular in machine learning, actually, rule 3 is an instance of a very simple neural network. Basically, think of combining these rules as neurons in your some artificial brain, and that's actually what a neural network is. And the idea is that these numbers, which rule appears, the 3, the 2, the 6, are the ones that we train using machine learning. So that's basically the goal of classification is if I find a way to put all my ham emails on one side and all my spam emails on another side, the model is just something that cuts it. Something that says, you know what, from here on, it's going to be ham. From here on, it's going to spam in some way or another. Any questions so far? Feel free to stop me.
And Luis,
Yes.
I'd say that the kind of the magic of machine learning is letting the computer figure out. I mean, you've plotted these dots on this slide in such a way that they're on a two-dimensional grid, and there's a line that cuts through them, so all the ham is on one side and the spam is on the other, and that's a great classifier. But the magic of machine learning is letting the computer put all of the dots that we have, in our data set on lots of different grids, on lots of different two-dimensional grids, and check all the lines and see if any are good versus bad, or put them on three-dimensional or four-dimensional or 18-dimensional grids. And so we're showing a very simple example of a much broader topic that really is what the computer is doing behind the scenes when the machine learning algorithms run.
Absolutely, yes. In a normal case, you would not have just two dimensions. You will have many for like many properties of the email, and you would have some way to separate them that is maybe more complicated. But if you see this line is simply an equation similar to the fourth rule, right? So the computer will sort of move the line around and find the perfect or a good enough fit that cuts it, and then it returns the rule to us. It's like, oh, what you want to do is, if this happens, you want to say spam. If this happens, you want to say ham. And then you decide, how much do I want it to be accurate on the spam side or on the ham side, which mistake is more expensive, etc. But the idea is basically, when you think of machine learning model, think of splitting data into two. And
yeah,
so
and can you go back 1 second? Sorry, can you go back 1 second?
More?
Nope, just the dots. Yeah. So the other thing to say is, like, maybe I'm letting the cat out of the bag here, but in my view, at least, computers don't actually learn. So that's kind of the dirty secret of machine learning, is the computer doesn't actually learn. Mm-hmm. The computer optimizes, right? And so what the computer is doing is we're saying the optimization here is minimize the number of mistakes that the classifier makes, or something similar to that. And so maybe that's actually what humans are doing when we're learning also, is trying to minimize the number of mistakes that we make. And so maybe it's appropriate to call this learning for the computer, but it's not. This isn't magic that's happening when a machine does it. It's really an optimization.
Yep. The computer just basically draws a random line here and says, how am I doing? Am I making mistakes? And obviously a random line will have a lot of mistakes. It will classify some points wrong. And so it basically just starts closely moving it towards the points towards the points that are misclassified in order to go further. And that's the process of learning. It's a sort of a slow iterative process.
Yeah, you could imagine dropping a line into this data that's sort of the wrong way, right? Something that's maybe perpendicular to the line that actually classifies it, and then wiggling that line around a little bit and trying to understand, okay, if I wiggle it this way, am I doing better or worse? If I wiggle it this way, am I doing better or worse? And that's how it kind of arrives at what's the best possible way to classify the data.
Yep, totally. I sometimes have this mental picture. You have the blue points are like positively charged magnets. The red points are negatively charged magnets. And you have a rod that is positive on one side and negative on one side. And you just throw it there and it starts going like this until boom, it just kind of gets all the, at the minimum energy state and just gets all the negative on one side and the positives on the other one, or as much as possible, right?
That's too much physics for me.
Too much, and for me too. We did math, physics, not physics. Great. So let me go on this slide, and these are some applications of machine learning and gaming. So I'll let Brian elaborate a bit more.
When I think about classifiers and their use in gaming, there's two big problems that come to mind, and one is anomaly detection. And really, if you look at industry, the biggest place that classifiers are used right now, probably, and you've all probably experienced it, is credit card fraud detection. So in the same way that emails want to be classified as spam or ham, and maybe that's the most used application of classifiers, but if you get a call from your credit card company when you run your credit card at the gas station, what's going on is the credit card company is looking at all your past data and saying, this is a geography that doesn't make sense for this customer, or this is a type of purchase that doesn't make sense for this customer. And it doesn't mean that it's not you. It just means that the computer said, hey, this looks more like a fraudulent transaction than a real transaction. And you know, it's a challenge for the credit card company to balance that because they don't want to call you every time you swipe your card. But that's kind of the core example of a classifier that I think of in business. And so this is actually really relevant to the gaming industry as well. So, for example, is a machine broken? Slot machine, for example, has lots of moving parts. It has a card reader, it has a bill validator, it has lights, things like that. And the slot machine communicates with the CMS and says, you know, hey, somebody just tried to swipe a card and it failed. That doesn't mean that the card reader is broken. It could be a dirty card. There's a lot of reasons why the card reader wouldn't have worked, but you could imagine setting a classifier on top of that data set and trying to predict, hey, is this card reader broken, or is it likely to be broken soon, or is it functioning normally and just getting, you know, the usual one-off card with a little bit of dirt on it, so it had a bad read or the guy made a bad swipe or something like that. So anomaly detection is one application of classifiers I think is pretty interesting. Feature extraction. So if you came to me and said, hey, I've got this group of players, or I've got this group of accounts, let's say. I have this group of accounts that I know is associated with a guy who made, you know, 200 accounts and he's doing something funny to get one over on the marketing program or whatever. You can actually look at the play behavior of the person using those cards, train a data set, knowing that that's a fraudulent transaction, train a data set with a lot of real data, and then go back through your historical data and try to pick out other cards that are likely to be associated with similar type of schemes. The other classifier, which you can think of as an input to your marketing program, is, you know, I have an offer. What do players look like who respond to that offer? Well, we build a classifier that identifies those kind of features, and it starts to predict, you know, on next month's mailer who's likely to respond and who's not. And it does that at an individual player level. Each player gets classified as either yes or no. Similarly, will a player play in a certain time period? Will they come in next month, next week to redeem this offer? You know, things like that. So classifiers have a fair amount of application in marketing as well.
Yeah, great to hear. Very, very nice examples. And if you can always think of classifiers as like, what is the yes and what is the no, right? So in the spam example, we had what is the spam and what is the no spam. So if you can think of each one of these examples and think of, okay, where is the yes and the no, right? Like the first one is, will a player play or not? The second one is the machine broken or not, right? And the feature extraction is actually going a little further, because in our spam example, not only, if you think about it, not only we figure out if things are spam or not, but we actually got to find features like appearances of the word by, or a number of spelling mistakes, and we can tell like which one ends up being more important to decide if something's spam or not. So in here, feature extraction is also what feature was more helpful in giving me the prediction I had, right? Okay, so I think we're good to move to the next of the three techniques, which is regression, which is probably one you've seen before more. Let me give you a simple example. So we have 5 houses, and the house 1 has 1 room, house 2 has 2 rooms, house 3 has 3 rooms, and you see where this goes. And I'm going to give you the prices of these houses. We actually live in house 3 and we want to sell house 3. So we look at house 1 as cost $150,000. House 2 cost $200,000. House 3 we don't know, but house 4 costs $300,000, and house 5 costs $350,000. So what do you think is the price for house 3? Any takers?
This one's my speed, Luis. So 250 looks about right.
Yeah, good job, Brian. Yes. So this one is $250,000. And why did we figure that out? We kind of just figured it out, right? Because it seems like the price of the house ends up being like $100,000 for base price, and seems to have 50 extra for each of the rooms. So our process of thinking there was machine learning, because we looked at the previous data, and from the previous data, we made a prediction for house 3. That's exactly what machine learning is. And in here, the previous data just forms a line. So that's why it's called linear regression. Basically, what happens is this: we plotted the houses with price on the horizontal, price on the vertical axis, and number of rooms in the horizontal axis, and we in our head drew this line, right? And that's it. That's pretty much what linear regression is. Of course, data is not going to look that pretty. It's not going to be points in a line, but it's going to be points that are somehow forming a line. And the point now is not to separate these points, but is to find the line that fits closest to them. Of course, this is a super simplified example, but you can think of, if I don't have 2 dimensions, but I have 3, there's just points flying in space, then I don't have a line, but I have like a plane. And the idea is that the main difference between classification and regression is that classification gives you a state, so a yes or a no, whereas regression gives you a number, gives you a value. So if you put in a new point here, if I were to bring a new house, house 7 or house 3.5 or whatever, like you would be able to guess the price of that house based on that line. So regression will find the value. And again, the way to find this is the same as before. How do I find that line that goes through all those gray points? The computer starts drawing a random line, and then the points say, well, come closer to me. So the line can, by moving if these words ring a bell, slope and y-intercept, by moving the slope and y-intercept very, very slowly, you get closer and closer to the points. And if you run this many times, you'll eventually get, hopefully, to a line that is a pretty good fit. So that's basically linear regression. Is there any questions? So any additions, Brian, or I can let you talk a bit about some applications of these?
Yeah, no, I think that's right. And so, the example that you presented is very simple. We plot price versus number of rooms, but a bedroom and a bathroom might have different values, and so really the regression might look like some linear form with bedrooms and bathrooms as 2 different dimensions and price is a 3rd dimension, or square footage might come in there, or size of the lot, or neighborhood might be an indicator, on this. What school do you feed? The actual regression that we would build for home prices is more complicated, but I think the point is the same. We look at data and try to understand the impact of each of those variables on the overall thing that we're trying to predict, which was price in that example. In gaming, and I'm guessing that actually a lot of people who do budgeting have probably used regression models to try to figure out things like the impact of macroeconomic indicators on next year's revenue. So what does unemployment mean for next year's revenue, or what does the price of gas mean for next year's revenue, or any of those kind of things. CPI, how does the change in the consumer price index impact gaming volumes? But you can do more with regression, and you can start to get at questions that are more impactful on operations. So, for example, you might want to understand not what's the impact of number of rooms in the house on the housing price, but what's the impact of inclement weather on visitation at your property, right? And this can have real impact on staffing, because if you've ever worked at a casino, you know that there's times when it's snowed and you've been overstaffed for the volumes that actually made it. Unless you work at a casino in Southern California or something where snow is not a thing, maybe then it's fire or rains or something else. Similarly, we can understand the impact of the location on the value of a slot machine. If you put a slot machine here on the floor, it's going to do $200 a day, and if you put the slot machine over here on the floor, it's going to do $250. Right, so use regression model to understand what are the impact of the locations. Predicting an individual machine's coin in, and this kind of thing can help to feed one of these classifiers where you're understanding, is the machine functioning normally or not? That kind of a thing. I love the application of regression to guest survey, which I think when we think about machine learning and gaming, we typically go right to the gaming floor and we go right to marketing, which are major areas where machine learning can have an impact. But, you know, I was shopping earlier this year for a projector for a different presentation, and I went on Best Buy's website, and at the bottom where it showed positive reviews and negative reviews of the projector, it gave kind of pros and cons of the device, and they were broad categories, you know, things that weren't necessarily mentioned explicitly in reviews. But so, you know, one application, and we can talk about this one actually in a little bit, is you know, process data and understand whether things are positive or negative. That's a classification problem. You know, in this case, I guess what I'm referring to is, like, we want to optimize overall guest satisfaction or likelihood to recommend. So you want people to give you a 5 out of 5 on those two topics. Well, if you go through the rest of your questionnaire, the guest is giving you a 1 through a 5 on a lot of different topics: buffet, valet, cocktail service, and regression can tell you, you know, what's the impact of each of those variables, the score for cocktail service on the score for overall satisfaction or likelihood to recommend. Maybe it's the case that the way that the guest feels about the buffet doesn't actually impact their overall satisfaction, or it impacts it minimally. But cocktail service is massively important. And so, you know, organizing the areas of the business this way gives you a sense of, how do I allocate CapEx? Where do I have to focus on retraining staff? Those kind of things, which I think are super important to operations. And what's great about them is we all have that data sitting around. If you issue a guest survey, you've got years and years just sitting there in Excel files waiting for somebody to take a look at them. It's not a costly thing to go out and develop that data. You know, the other thing, you know, Luis said classification gives you a yes or a no, or a 1 or a 0, where it tells you if an image that you're looking at on the computer is a cat, a dog, or a kangaroo. And regression gives you a number. So in the same way that we could predict, is a player going to show up or respond to a campaign, we can predict how many times is a player going to show up, what's the worth of the player when they do show up in response to a certain campaign, let's say, or event on property, let's say. So again, lots of things that, lots of applications, I guess, of regression to operations of the gaming floor. Luis?
Can you hear me? I think I got lost for a minute. Are you there?
Oh, I can hear you. Yep, we're all here.
Okay, perfect. Yeah, I think I lost everything for a bit. So yes, I think. So yeah, great examples. I think, yeah, the rule of thumb is: do you want a number? Regression. Do you want a yes or no? Classification. And actually, your examples reminded me of one of my favorite examples of an experience of mine when I was at YouTube doing a video.
Uh-oh. Hey, Luis, I think we're losing you.
Your audio just got choppy, Luis. I think your Wi-Fi might be goofy right now.
Your recommendations. So the question was, how do you recommend the best videos? Hello?
Yep.
And all of a sudden, we start getting a lot of clickbait, a lot of garbage, because sometimes there's something with an explicit thumbnail or something that's not exactly what the thumbnail says, and you click on it. A lot of people click on it, and those get recommended a lot. And so the answer to that was not use classification, instead use regression, because now if we try to predict instead of click. Oh, can you hear me?
Luis, yeah, so you cut out for the entire first part of your example, which I think is a great example that we've talked about offline.
Yeah.
Could you just kind of
start
over? Yeah.
Sure. Just feel free to stop me at any moment if my connection is bad. I'm not sure what's happening here. I think people are just waking up in Silicon Valley and just start logging their computers, so it went slow. Anyway, let me start again. So at YouTube, we had a problem, which is how do we recommend videos to users? and we try to recommend them whatever they're most likely to watch. So that seems like a classification problem because it's either you watch or you don't watch, right? So we try to recommend that, and we ended up recommending a lot of garbage because there's clickbait or things that explicit thumbnails or maybe fake videos that are not exactly what they show in the thumbnail. You know, like for example, you see the thumbnail of a game and you click on and it's not a game, it's just a picture of the game with somebody talking in the background. That kind of stuff, we're recommending that a lot. So we thought, what can we do to make recommendations better? And it turns out that regression was our friend there instead of classification, because we try to predict, instead of a yes or no, click or no click, how much time will the user watch the video? And it turns out that the videos, good videos, are watched a lot longer. If it's a bad video, click and you feel bad about yourself and you leave immediately, as opposed to taking a long time watching the video. So it turns out that regression helped us because the predicted watch time just ends up being a lot more than a lot more information. I'm gonna go back to the presentation here. So great. Well, feel free to ask any questions about regression classification. We're gonna move into a slightly different topic. You're gonna see that it's a different type of algorithm, but it's very important too. It's called clustering. So let me go to clustering. So I'm gonna give you the following problem. Let's say we're a company and we want to make a marketing strategy for our customers. Okay, so we actually want to make 3 marketing strategies, 3 different marketing strategies aimed to 3 different sets of customers. And so we have, for our customers, we have 2 pieces of information: the age in years and the engagement with our hypothetical page, and like how many days a week are they engaging with our page or with our app or whatever. So I'm going to show you some people. This is a data set of 8 people with ages and levels of engagement. And I actually would like you to take a look at it for like 30 seconds or something, and tell me if you see 3 different groups there, or some different groups. If you see people standing out in different clusters, and feel free to take a look and put in the comments if you find anyone in particular. Meanwhile, I'll look because I actually don't remember. So let's see. There's some people. What do you see, Brian? Anything interesting there?
I see a 49 and a 51-year-old that have low engagement.
Yeah, that's one.
But I also see a 42 and a 37-year-old who have high engagement.
Mm-hmm.
And then I see young people, 18, 23, 20, that have kind of 2, 3, 4. I don't know if that's medium, maybe.
I can say that. That's. So I think, yeah, you spotted the groups pretty well. So this can be eyeballed, right? Imagine if we have 10,000 users, and not just age, but age, engagement, and like 10 different demographics or different behavioral metrics. So we can eyeball it until a certain point, but after a certain point we can't. So it may be quicker to eyeball this if I actually plot the users in a graph where age is horizontal and times of engagement per week is vertical. So there you can see them. Now you see the 3 groups, right? You see in the people who are in the 20s and with medium level of engagement are on the left. Then the people who are in their 30s, late 30s and early 40s and high levels of engagement are on top. And then you see like the people in their 50s and low levels of engagement. So that seems to be the thing to do. If I want 3 marketing strategies, then I have 1 marketing strategy for these people, 1 different marketing strategy for these people, and 1 different one for these people. Yeah. So that is what clustering does. Imagine thousands of people. Imagine thousands of metrics, age, engagement, many other things, and some, the points are just flying in space all over the place. And our algorithm will just be like, okay, you know what? I think you have a little cluster here. I think you have a little cluster over there, a little cluster over there. And we'll just, there's many different algorithms. If you've heard of K-means, hierarchical clustering, all kind, DB-scan, all kind of things. But basically when you have your data and you don't necessarily want to predict things, you just want to group it into groups and see how they, and in order to sort of break it down a little bit, it's more of a pre-processing step, then you run clustering algorithms. So basically, yeah, your data looks like this all over the place, and your clustering algorithm does this. So 3 things we saw today: classification, that's yes, no; regression is predict your number; and clustering, which is, I don't know about your data much, but I'm gonna like group it into little groups. And as you can imagine, clustering has a lot of applications in everything, in particular gaming. So what are some cool ones, Brian?
Can you go back to either the dots or the people? It doesn't matter.
Let's go to people.
You know, in the first 2 examples, what we were doing was we placed a line into this 2-dimensional illustration of the data, and we tried to, in the first one, we tried to separate the spam and the ham, and we tried to move the line around until we got good separation between spam and ham. And in the second one, we tried to make the line very, very close to the data, and you didn't want data points that were very far away from the line, and that would be sort of a bad thing for your regression line. In this one, what you can imagine is dropping, and we're fortunate that we get to start by saying, hey, we're going to try to put these folks into 3 groups. Right, and in a lot of cases, we don't know how many groups we want to make at the beginning, so we have to make, we have to see what it looks like when we make 3 groups, 4 groups, 5 groups, 11 groups. But for the 3 groups, what you can imagine doing is dropping 3 points onto this grid, and then letting the points move around. And as they move, you can say, okay, are the people closer? The people kind of associate with the closest point to them, and by moving the point around, have we made the groups better, as in closer to that point, or worse, as in further away from that point? I mean, if I were to drop a point way up in the top left of this graph, that point is going to be very far away from almost all the groups. But if you imagine a point at the centers of the 3 circles, now the sort of looks naturally like clusters. And so what the machine learning algorithm is doing behind the scenes is moving those points around and trying to get them to find the centers of groups. And like a natural problem that kind of illustrates what it means to find the centers of groups is, imagine if you're in a small city, and the small city has no McDonald's, and McDonald's wants to come in and drop 3 stores in the city in such a way that it can service the whole city best, right? What it's really doing is trying to take the city and divide it into 3 clusters: the cluster that goes to McDonald's A, the cluster that goes to B, and the cluster that goes to C. And it's trying to optimize the positioning of those 3 locations so that the people are kind of clustered around those center points. And that's really the same thing that Luis did here with these people on the age and engagement grid. Sorry to...
Absolutely. That's great. That's a great description. Yeah, that's K-means algorithm that what it does is basically, thinks of people as like customers, and then where if the people lived in the city, where would you place 3 McDonald's? So you place them randomly and then start moving them towards the people slowly. Another way to do it is the following. You say, what is the closest 2 points here? Let's say it's maybe the 2 people on the bottom right. So let's join those 2. And now we have, instead of 8 people, we have 6 individuals and 1 group of 2. And then you say, okay, what's the next set of closest 2 people? Maybe the 2 on top. So you join those 2, and you start joining points based on which one is the closest 2 points, and then start making sort of groups and groups until at a certain point you're like, okay, I can't join these 2 points because they're far away. But yeah, basically there's a lot of great, very clever algorithms that can help us cluster data like this.
And so,
yeah,
I mean, from a gaming side, the things that we might want to cluster, well, there's sort of 3 things that we might want to cluster. At least when I sat down to think about this, there were 3 things that I might want to cluster. The first one is people, the second one is slot machines, and the third one is marketing offers. And so clustering people is guest segmentation, and we all do that when we send our monthly offers out. But maybe you have a player worth component for the marketing offer. Maybe you have a frequency component for the marketing offer. If you plotted all of your all of your customers on a two-dimensional plot with worth along the bottom and frequency, up and down, then you're doing, when you make your marketing segments, you're doing exactly what Luis just showed, and you're sort of bundling those people into an ADT frequency group or whatever you're actually doing. So we're doing sort of a natural. This would be segmentation that A, allows a lot more variables to enter into your segmentation model, and B, it's not prescribed. Nobody is sitting in an office saying, we've got to cut it at 100 ADT. We're letting the computer tell us, no, you might not want to cut it at 100 ADT because, there's a lot of people that look very similar that are a little bit above 100, and there's some separation to the 150 or 200 category, whatever the actual data looks like. Again, another thing that you might want to cluster together is slot machines. And, you can do some pretty interesting analyses of floor layout where you're understanding that two machines are, we'll say, close together if similar looking people play those machines. And why do we care that similar looking people play those machines? Because when somebody gets up from one machine, we want them to be looking at other machines that they're interested in playing and not the door, right? And so from an engagement perspective, you want machines near each other that attract the same group of people. And so that's a clustering problem. And then similarly, marketing monthly mailers, what do they include? They have a coin offer, they have a food offer, they have a hotel offer, maybe they have an entertainment offer. But you know what? Maybe all you needed to send me was the entertainment offer or the food offer and not the coin offer. And so you can start to ask, what's the right bundle of offers to send to each of your customers and you can optimize on engagement, you can optimize on profit, but at the end of the day, you're doing some sort of bundling there, and that's really a clustering problem, similar to the one that Luis just showed. So I think again, these are three big machine learning paradigms: classification, regression, and clustering, and there's examples of how to use all of them to make a gaming business, or really any business, better. And what's fortunate about us on the gaming side is that for many, many years now, we've been incredibly good at collecting data, but we haven't been the best always about using that data to improve the operations. And so now that machine learning is becoming more standard, more prevalent, easier to access, I think there's a huge opportunity there to pass some of that data in and answer some of these problems that we've really kind of opined about and just used our gut to answer for the last 40 years. So it's a pretty exciting time, at least in my mind.
Yeah, certainly for other industries as well. For many industries, it's just a very exciting time. Finally, we have basically data everywhere. Everything we do collects data, and the computing power to run these algorithms very fast and very accurately on huge data sets. So it's definitely breaking every industry. Recommendation and even education, health, everything is being revolutionized by this. But as you can see, it's very simple. It's very simple methods, right? It's how do we think? How do we make decisions? Okay, well let's transfer that to the computer, basically. So yeah.
Yeah, I mean, we didn't really even touch. We didn't even touch recommendation engines. I go into Gmail now and I start typing, and Gmail in light color text starts to complete my sentences for me.
Yep.
Right? That's machine learning. It's predicting what words are going to come next.
Yep.
Netflix tells me what I might want to watch. That's machine learning.
Yep.
As recently as a few years ago, 5-6 years ago, companies were sending slot machine recommendations. That's you played Buffalo, you might also like Sun and Moon. That's an example of something that you could use machine learning for, and we have so much data on what slot machines people touch, and everybody has that data. There's no oh well, we really don't have our data integrated, I can't join my point of sale data from the buffet with my gaming data yet, so I don't know if I can really take advantage of this. There's plenty to do just with your marketing data and your slot data.
Absolutely.
So I think we have about 10 minutes left. So now would be a good time while I'm kind of waxing philosophic about how this is a great time for the industry. If you want to get a question in the chat, I don't know. Should we kick it back to Marie, or how would you like to do this?
I do see a question that came in. I flagged it in red. If you guys can see it.
From Ben, let me read it. It sounds like a lot of this requires guessing and checking what data we use, what lines we draw, what algorithm to try. Is it really a guess and check, or are there better ways to implement these? And how do we know if finally good? Great question, Ben. Let me tell a little bit, and then Brian wants to elaborate. Basically, it's like educated guessing. There is guessing, but there are certain ways to start at a good spot. So, for example, if your weights are huge, that's not good. You want to start your weights in like small values, normally distributed, similar. You wanna guess. You wanna be making very small steps towards a better solution. So if I want to do a line, like I would just kind of center my data, put it in a small square here or a cube, and then put a line somewhere there, as opposed to like over there. Make small steps to get a little better and better. And I may get to, like, let's say, a minimum value of my error function. I may do really well, or I may get stuck in a local minimum. So the only way to fix those kind of things is to try different ways. There are techniques that make you guess in smarter ways. But yes, there is a lot of basically educate, guess, and iterate. And how do you know things are good? That's a huge question. I'll give you an example. Spam message. What if I have a classifier that makes, let's say, 10 mistakes and one that makes 1 mistake? Which one is better? Maybe you'll think that the 1 mistake is better, but what if that 10 mistakes is 10 spam emails on my inbox, and the 1 mistake is the message from my grandma that I didn't receive, that she made cookies. I missed out on cookies. So that 1 mistake is more expensive than those are 10 mistakes, right? And the same thing in medicine, right? Like if I might misdiagnose a patient, it's different if I send a sick patient home with no treatment than if I do extra tests on a healthy patient, right? So it's up to a human to make these decisions, and that's why there's data scientists all over the place. But once you build an error function and you create you put your human input, then you let the machine run, and then it's back and forth. Then the data scientists look at it and say, okay, well, this seems good, this seems a little off, let's try again. So it's basically, as you said, it is guess and check. So I'm just gonna say it's educated guess and check. Yeah. There's another question.
And sorry, yeah, no. From my perspective, the answer is, you have all these dots, and for me, I would drop a whole lot of random lines in there and just keep track of who does the best. And as Luis said, it's not always obvious what's the best. And so the gaming example of this would be, predicting who is going to show up next month. And you might say, well, if this guy's going to show up anyway, maybe we don't need to send him an offer. Or if this guy's not going to show up anyway, maybe we could send them a really healthy offer, to try to get them in. But if I'm wrong and that guy was going to show up anyway, and now I've doubled or tripled the offer that he was supposed to receive, now that really costs me, a lot of money. And similarly, if I'm wrong on the other side and I reduce an offer for somebody that I think is going to show up and now he doesn't, that's a real problem. So there is a lot of, and maybe that's a learning problem in and of itself. How do people react to the changes that I'm going to implement? And we can kind of hone in on the optimal answer there. But from a just what's the best line to cut through the data perspective, which I think is the question you were asking, we try a lot of random starts and let those things try to wiggle their way to the best solution they can find, which isn't always the best global solution. It's just the best one that they could wiggle to, which is why we start with a lot of different lines. There's another question down here that asks what gaming companies are currently using machine learning. it's sort of a loaded question. I would guess that almost everybody in the industry has an analyst that's doing regression for something. Again, whether it's even if it's as simple as budgeting, or computing ADT or something like that. I mean, they're modeling this data somehow. Who's doing advanced machine learning? I only know of a handful of folks in the industry that have the background. So I think what's good is that there's a lot of software out there now that's making machine learning more accessible. But kind of as Luis has alluded to, even experts are getting things wrong, and I don't know, some of the software is kind of like giving a Ferrari to someone who doesn't know how to drive stick. You can end up with some bad outcomes there. I don't think that anybody is using machine learning in a way that it's worth talking about on the earnings call, if that's a simple answer to your question. Sorry. So somebody asks, and this is obviously I couldn't have asked for a better question. They say, "Hey, Luis, this pitch seems more for why people should enroll at Udacity. What is Innovation Group providing?" Maybe I misunderstood what this webinar was about. Look, I think Luis can talk about the benefits of enrolling at Udacity and some of the stuff that they do. And I've enjoyed several videos of Luis teaching machine learning topics that are available on YouTube. And I'm sure that's just a small teaser of what he offers, as his services. For our part, we have a data analytics arm, and but I don't want to turn this into a pitch, but we have a data analytics arm that offers these type of services if folks are interested in discussing what problems can we solve and how do we solve them.
Yeah, no, certainly. I mean, in the same way that it's a two-way street, applications and machine learning. Like there's machine learning benefits from places like gaming where you can apply all these techniques and gather data and improve things. And industries like gaming benefit from machine learning. So in the same way that's a two-way street, yeah, we have like here where if people are interested in learning machine learning, certainly there's online courses. Take a look at Udacity, things like that. And but yeah, the aim of this was to get people interested in gaming to and sort of find ways to implement it in their daily life. And also people interested in machine learning who have interested in gaming to see how it applies. Yeah. Cool. Oh, there's another question. Oh, thank you. Thanks, Nicholas.
Yeah, I was going to say it's 10:59. So if anybody's got another question, it would be great to hear from you in the next 30 or so seconds. Otherwise, I think Marie's going to wrap up the webinar.
Yeah, I just wanted to say, Luis, thank you so much for your participation. This was fantastic. Attendees, we invite you to take our survey at the end of this, as well as visit us on the innovationgroup.com to see how to join our mailing lists or follow us on social media. And thanks for joining. We'll see everybody next time. Stay tuned for the video. I'll upload it in the next couple of days.
Great. Thanks, everybody.
Thank you, Mom. Thanks for everything. Bye.
Thanks, guys.